Hello, welcome to Bedroom Builds at the From Python to Rust series, episode 32, SQLite, coming from the previous episode where we spoke about HTTP servers. So SQLite is a part of the standard library in Python. So you will have that available on any Python install, which is very practical. This is used via the DB API 2.0 version. Rust has, for example, a wrapper library for the SQLite C library called sqlite. This is a very powerful crate with lots of features already implemented. So if you're looking to use SQLite, I highly suggest to use that. However, there is an interesting project called sqlx. They try to give you one single API to any database using mostly async calls. However, in the case of SQLite, the async support is limited. The reason is that the operating system's file system layers do not really implement async calls right now, and SQLite is treating a single file as the database storage layer. So if you have an async library, it will do the actual blocking calls of SQLite with an async wrapper, more or less. And on top of this, SQLite is not meant to be used by lots of parallel queries, especially when it comes to modifying queries like inserts and updates. In order to have some data to play with, I was Googling around to find some datasets that are legal, easy to understand, and somewhat open for anybody to use. And I found this COVID-19 India API, which is a really cool project. And everything of this project is completely open source. That includes the user interface and everything. So if you look at their website, as you can see here, it even has a dark mode, which is pretty cool. Really cool user interface. And when you scroll down, you can see that all of this is available on GitHub, and the API makes it easy to download data. Now, in order to understand at least a little bit what we will do today, let's look at the data first. We have the CSV data that was downloaded. It's the file called case time series CSV. So there's lots of details information that you can download from this API endpoint. And here are the column names. So the first one is date in human readable form. After that, we have the ISO format. And then we have different types of numbers that have been counted. So you would have like daily confirmed cases, total confirmed, recovered, and so on. And below that, you can see the rows coming in for every day since the end of January 2020. In order to import this, we can, of course, write a small loop in Python or Rust to deal with the CSV data, which is fairly easy to do, but this has been implemented in SQLite already. So when you use the SQLite command line tool, you can feed this SQL file that you have on the right here into the tool. The .import is a special command offered by SQLite. You can call this with this CSV flag. So this makes it comma separated as is used here. We see the commas separating the columns and also the data. And once we've done that, we can use the CSV file as an input, and then we give a table name that we want to have this imported to. The disadvantage here is this is all done into columns of SQL of the type text. Since we want to do math with the numbers of the confirmed cases, for example, we need to have the proper data type. Now, a quick fix to do that is you create your actual table that you want with the correct data definition. So we would have a timestamp for the day and then integers for everything that is the counts that you find in the CSV file. Since we do not need this human readable format in our data that we import, we can use this feature of SQLite to alter the table and drop the column date. And this gives us the luxury to then use the star operator here to select all columns when we actually copy the data. Now that's the next step, right? So we have imported CSV, we dropped the data that we don't need, we created the table that we want to use in the end with integers and the timestamps. And once we've done that, we can create an insert call that uses the result of a select to do the insert. So all we do now is select every column from our imported cases CSV, and SQLite will be smart enough to convert the text columns into the respective data type. So in our case, just integer and timestamp. Once we've done that, we can get rid of the imported data. We don't need it, so drop table. And for my example code, you will see later, to see how inserts work, we create an extra table that is basically like a materialized view of an aggregate information that we can query out of our cases table. So here we would aggregate the information on a per month basis. Let's hop over to our code. On the left, now as usual, the Python code. On the right, we have the Rust code. First thing we do in Python is import the SQLite 3 module. And then we can actually already define the queries that we are going to use. So the first query would look up the best day for India in this context, if you want. So that would be the most people that recovered on that day from the virus. And then we can also group by month, where we would then create the monthly grouping here by year and month. So we can separate 2020 and 2021. And we would count the sum of all new cases in that month, but also the sum of all recovered cases in that month. So now we have defined those queries to make it easier to read our code that now follows in our main section. We created this SQLite file that we can open with SQLite Connect. Then we use this row factory to have access to the column names when we do our queries. And then we just set up a connection for reading and a connection for inserting. We use the cursor for doing a query to get the most recovered results. And this will only be one line. And then we print the most recoveries. And here we have a ticked expression that we use the key, so the column name and the value coming out of this zipped keys and values from our row. The SQLite row type by itself will not be accessible or printable. You will have to either use a list or tuple, as in this case, to make it a tuple that you can iterate over. Now, in order to build our materialized view of our monthly cases, in order to update our materialized view for our monthly cases, we will have to delete the data first. And once we've done that, we can use the reading cursor that we created to run our group by month query, which will give us the month view and the recovered cases. And then we print it out because we want to know this information. But at the same time, we can use the second cursor that we've created to insert the data that came out of this. Then we can use the insert into month cases. We give the column list that we want, and then we give the values with the placeholders for the query preparation, and we pass in the values that we want. With this question marks, the API makes sure that the values found in the row will be correctly escaped to form a query that does not allow SQL injection. So always use this way and do not construct strings with values that you have no control over. And at the very end, we commit the changes that we've done, and then the database is updated. Now in Rust, that's not too much different. We would import the needed stuff we need from SQLite. Then I created a helpers module that I will show you later. This is necessary for Rust to work with SQLite or any other data source, because we have to predefine the data we are dealing with, or we have to write our own automagic functions that can deal with certain inputs. So here we use a static string to define our query, and this is a raw string. And if we had, for some reason, double quotes inside our query, this would then still work, because the raw string stops with the pound and quotation mark, as you can see here. Same is done for the second query, but you can see multi-line queries can also be written only with a single quote. as you can see in the insert example further down. Now we define our main function with a result type. This is very practical because now we get to use the try operator, and this makes the code easier to read. The connection is created in a very similar fashion. So this one line is exactly this one, connection open, and then path to the SQLite file. Then we can prepare the most recovered query. And then once we've done that, this statement can be handed to the query row method. Here we can pass parameters, but since this query is self-sufficient, we don't pass any. And then we have the helpers modules row to string vector. Instead of passing this function, you can of course also directly write a closure in the place. I didn't because I only have limited space on my presentation Vim, so I chose to write a helper function that I will show you later. This will create, as the name says, a vector of strings, which is not the same as we did here. Here we created a dict, but I also implemented a hash map, which would be more or less a dict. This will then be a hash map of a string key mapping to a string value, and then this will be a similar output as we have in Python. And that's why I chose to use the most recoveries text then here. Same thing as on the left, of course, we need to delete the monthly cases first. So all those question mark operators, the try operator, will then exit for the exceptions that can happen on the SQLite side, which can be plentiful, like you can have a syntax error in your SQL query, you can pass invalid values, it may not be possible to convert the value from your requested type to your local Rust data type, and more. So here we run the same thing as above. We prepare the group by monthly query, as we did here with our most recovered one. But then instead of the query row, we now use query map method. Again, we have the optional parameters, but since the query is self-sufficient, we don't pass any. Then we have our closure that gets passed the row for every result of this query. Here we call the month case constructor from row. So here you can pass the SQLite row type. This will create a month case struct, and then we wrap this in an OK. This then generates an iterator for us. So you see here down below that I can use for month case in the month cases. Here I basically unwrap it with the question mark operator to then directly have a month case available in order to print it. And this is then basically this print tuple row. And in order to insert it, we can do the same. I will quickly disappear to show the full code. So on the con execute, we have the normal insert, and here we have question mark, and then argument 1, 2, and 3. So that's a bit different. Here we only have question marks. Here we have to denote the number. And then the first one is the month, second one is the new cases, and the third one is recovered. The library also allows for you to name those placeholders, which can be very useful. So you might want to look into that. And this concludes that we can use the query data coming out to insert into our materialized view. Now I will close this code and hop over to a new view where we don't have Python on the left and Rust on the right. I will have the helpers library on the left and our Rust code on the right to show you the helpers that I've written to make this code more concise. Okay, here we are. And the first one we should look at is this row to string vec function. You can see here on the left, I have documented it even. So this one gets passed a reference to an SQLite row. And with this borrowed item, you then can access the columns. Columns will give you a column type that you can inspect later to figure out what column type the column has, but also like the column name and stuff. Then in order to make this generic over any result, we would iterate over a range of the column count. Then we can map that. So now we have the column index that gets passed into our map closure. And here we can match for the types of the column. And this can fail, of course, but we know that it won't because we are only going over the column count. So this will work for sure. We can use unwrap here. And then after we've done that, we can figure out with the decal type to give us the type inside of SQLite for that column. So this will, for example, return the some timestamp and some integer in our case. In order for this to be really generic for any row coming out of SQLite, you will have to match for all possible types, but that is not really necessary. I just wrote this code to illustrate features of Rust. There is very cool features that you can enable inside the SQLite crate. For example, the SerDes.json one. This will then deserialize and serialize into the SerDes.json's value type. So this would mean you will not have to write any of this. You just run your row and convert it into a value type, and you will be fine having a JSON compatible output, for example. So very likely my implementation here is available somewhere in the crate. But again, this is to illustrate the API that SQLite offers you. So now back to our data types. After we have matched against the data type, so in our case, timestamp, for example, we will then call row get unwrap, which we can call because we are very certain that our column index is a correct one. And here we provide the two generic types that have been assigned to this get unwrap method. So usize is for the column index, and then the data type that you want to convert to. So if you were to let x equals row get unwrap and you give x a data type, it will try to convert the SQLite value into your data type. Since we want to create strings only to have it easier in our data definition, we use a string here. So this already returns us a string. So we use format to create a string of our integer. Again, with the unwrap, this time into a U32, because this is an integer at the base. You cannot directly convert it into a string. You have to do it indirectly. Another option instead of the format trick would be to simply append a toString after this parentheses. This can, of course, if there's another query row coming in with that doesn't match to either of those two data types, we match to any other. And here we then tell people that we don't know how to treat this. Once we have done that, this can be collected into a vector of the type that is coming back from the map. So string will be auto decided by the compiler, and therefore this function returns the result vector string and potentially a SQLite error. This is the function signature that the closure has to fulfill for it to be passed to this query row. Now, in order to create the hash map, as we did in Python for our dict, the same trick works. The only difference is, of course, the return type now becomes a hash map that has keys of string and values of string. And to create a hash map from an iterator that we collect into a hash map, we have to provide tuples. How do we do that? Well, we have access to the column names. This can be found out by the row column name method. We pass in the column index. Since we know this will work out, we have the unwrap. Then we make it owned. So this is now a string that we can pass into. That's the same thing as above for the vector. But now we create a tuple that has first the column name and then the value, which is the same code that we had in our vector. And the same tuple we create for integers. And of course, in our other case, we would also create a tuple, but let the people know that we don't know what to do for this column name. So this has treating of those helpers. You could write this, of course, as a closure directly here in the code, but this will make it fairly unreadable. As you can see, those two already take up a whole page. This would not have shown concisely how to interact with SQLite. Okay, let me continue further down in the code of our helpers. In order to convert the data we have selected from our aggregate query here, the group by month, we will have to create a data type, so a struct in the case of Rust. So we have this struct month case that maps to the column names of the output. So we have month, new cases, and recovered, month being a string, and new cases and recovered being integers. Once we've done that, we can implement our constructor from a SQLite row. So we get handed our reference to the SQLite row. And with this borrow, we can get the first column into month, second one goes into new cases, third goes into recovered. This then is returned, and that's exactly what happens here in the month cases. So now these MCs here will be month cases structs that came out of here. And what we can, of course, also do once we have this struct, for example, implement the display trait, and this will then format the output of our month case, and we can print it. And of course, we can use the properties of our struct in the parameters for our insert statement. Now let's quickly run this Rust thing. And you can see at the very top, we get our vector of strings printed from our best day for India, where most people have recovered. And then below, we get the info with the column names, because figuring out in this vector which number means which is fairly hard. The disadvantage of this quick fix solution to quickly print our rows is that all of these are strings, so you cannot easily do math further down the road. And here below, you see our formatting of our display trait implementation going through our monthly accumulated data, where we would have the month afterwards, the new cases afterwards, the number of recovered cases. So thanks for watching. Coming up next in the From Python to Rust series will be PostgreSQL.